Tu požiūrėjau jis taip Waszyngtonie na zjeździe Marsosjecie ma Harrison Smitt, ostatni astronauta na Księżycu.
Ways in which you can abort the land. You go all that distance, all that cost, and you abort to come back home? I don't think so. You've got to think it through, abort the land, work your problems after you get back on the surface, or get onto the surface. And that unmanned precursor that I mentioned before obviously can have a beacon on it to which you can land, so you land close enough, you have a surface rendezvous, and that will, I think, make the whole operation, once you're there, much easier. That's a long-term habitat and operation center. The consumables will be there: food, water, oxygen, fuel production, test gear. You're certainly early on going to have to test whether you can get all of those consumables available to you from Mars resources rather than having to bring them every time you come. You'll need the rovers, exploration and analysis equipment, and spare parts, systems, and suits. I hope you all remember that the Apollo suits were qualified for 6 EVAs. After 3 EVAs, I can tell you from experience, they probably could do 6, but they were showing an awful lot of wear and tear. And it was only about 8 or 10 years ago I realized we did have a single point failure in that suit. It had to do with a one cable in the arm, that if it broke, your arm was going to be up like that. And you're pressurized, so how do you get back in the lunar module or spacecraft? So we did have it, but those can all be taken care of with good engineering. We're going to have to definitely have better suits, but still that's an engineering challenge. Well, I'm not getting anything out of this one. These are the exploration challenges that we're going to face. We got 3H gravity on Mars' surface. There is radiation. It won't be as bad as the moon. Most of the radiation you have to deal with is from the zenith, but still that is something you have to be concerned about. Consumables are important. Again, a challenge to have enough and to produce your own on Mars as soon as you can. And you're going to have, I believe, a nuclear power system of some sort on the surface of Mars. And one of the best places to learn how to have such a system and operate it, and what the challenges are going to be, will be, of course, the surface of the moon. We'll talk about that here in a moment. Maintenance is going to be critical. The communication delay is something that we'll have to deal with. And we've talked about that already to some degree. Integration of Earth capabilities into exploration planning and analysis, I should add. That great Earth will become that great computer in the sky that allows you to gather analytical information, synthesize the information that's being collected, and make it available for future exploration on that particular mission. Integration of orbital assistance into the activities I think will be an important part of it, particularly if you take 2 crews, 2 landing crews. Forward and back contamination protocols. That may be, to some degree, the Achilles heel of any Mars program. We're going to have to be very careful that we don't scare ourselves to death, and because of that, never go to Mars. I am seriously concerned about that. Sample and data analysis. Both for sample selection and return, and also in situ hydrosphere, cryosphere core analysis. If we're going to find extant life forms on Mars, I think it'll be at that interface. That's been the geologically stable interface on Mars throughout most of its history. If we had the initiation of complex molecular and replicating life forms on Mars early on that we had on Earth, then if they've survived at that interface. I don't think they'll be very complex, but if they're there, we're going to have to figure out how in the world do you find out that they're there and also keep them there, because you don't know the consequences of exposure. Data synthesis, archiving, and retrieval for real-time utility. That's probably where the Earth comes in and plays a very critical role, is being able to provide that kind of synthesis, archiving, and retrieval, for planning purposes anyway. Now, this slide was to discuss the deep space, or the role of the moon in the Mars program. The moon requires similar deep space operational discipline. It's geopolitically important in its own right. The private government partnership is feasible. Important new science while preparing to go to Mars can be obtained. And in the question of Mars transit, then the moon provides you with a radiation lunar protection through a lunar water jacket. Well, you can produce, by the way, water anywhere on the moon. You don't have to go to the poles for ice. All you do is heat the regolith, and hydrogen reacts with the oxygen-bearing silicates, and you get water. Now you have to heat it to 600–700 degrees C, but with solar energy that shouldn't be a big difficult. So just remember, you don't have to go to the poles. You may want to for other reasons, but you don't have to go there in order to produce water. Food, I have a very strong feeling the moon is going to be very hospitable to food production, oxygen and nitrogen, propellants, and the like. Shorten the transit time. One of the things that helium-3 fusion is particularly adept at is fusion rockets. And in the vacuum of space, you don't have to worry about a whole bunch of things that you have to worry about here on Earth for power production. If you can accelerate and decelerate continuously, then you can shorten that transit time and remove some of the risks of transit. We've talked about using the spacecraft as simulators for training, crew compatibility. We may want to evaluate that with extended working stays on the ISS, then on the moon, and then back to the ISS. Basically put together a Mars mission for the crew up to some degree before they actually go to Mars. The role of the moon in test, training, and operational preparation. Embed deep space operational discipline. Lander, habitat, and rover designs can be tested out. There's no reason why you can't use Mars designs on the moon. Dust mitigation is going to be critical on Mars as well as on the moon. Nuclear power system design and operation, the same. Small-scale consumable production and experience in doing so. And again, with all four of those, the primary fuels you can produce on the moon, of course, are hydrogen and methane, in addition to the helium-3 for fusion rockets. The role of the moon in tests and training and operational preparation is simulation and tests for real situations on the moon. Nothing beats having real situations. We put together the geology training program for Apollo, the later missions, 13 and beyond, as real-time simulations, but on real problems. And it made all the difference in the world in the attitude as well as the learning of the pilot astronauts. We're going to have to learn how to do autonomous, accelerated entry, descent, and landing. That can be done in various ways at the moon. Beacon landing can be done. Abort to land certainly can be conceptually as well as realistically used. Autonomous exploration, you just put in the communication delays that are going to be excellent with Mars. The sample and data analysis, the same. And that business of in situ core analysis, avoiding cross-contamination, that certainly can be tested on the moon. Forward and back contamination protocols can be tested. You know, you have submicron dust on the moon, and if you can't keep submicron dust out of your systems and habitats, well then you're not going to do very well on Mars. So the moon is a great place to figure out how to do that. Orbital mission assistance is going to work as well. Now finally, the role of the moon in Mars physiology. Big question is, does 1/6 gravity trigger readaptation sufficient to operate in 3H gravity? My guess it does, but I don't know that. We never tested it. We were there 3 days. I felt like I was readapting, but I don't know that. I can't prove it. If the answer is yes, the feedback into design and operational planning will be very important. That means less complexity and less cost. If the answer is no, however, the feedback into design and operational planning will mean more complexity. We may have to develop the 3H gravity physiological countermeasures and readaptation protocols, and that readaptation will take time. Once you're on the surface, if you're not adapted, then it'll take time to adapt. A long space station stay before a crew goes to the moon may be something that we want to think. Now this picture that you're not seeing is a picture of the Earth, crescent Earth rising behind the moon, and with the caption, "So before Mars crew has a parting view of the Earth." And this was a Martian sunrise. And for months later, greeted by Martian sunrise. Then it's about time we take another walk on the moon. Thank you very much. Do I have time for questions?
Yes, you do.
Good evening. Thank you for an interesting talk. I have the experience of bringing your moon rocks around to Silver Patrol audiences time and again, and I'd like you to refresh me on something. What is that mineral that you got named for yourself, the orange soil?
I don't think that anybody has named a mineral for me.
It's a NASA briefing that you got orange soil, the stuff you found.
Yeah, well, orange soil. Well, the orange soil is certainly something that I found. It's made up of little tiny beads of volcanic ash.
Yeah.
Glasses. Their average grain size is 40 microns, so we weren't able to see what it was when we found it. And it is volcanic ash, and it's underlain in that particular location. The geological story is more complex than this, but it's underlain by black beads,
right,
which are partially devitrified. And because the devitrification changed the iron-titanium ratio, the color changed.
Okay.
And it became very, the glass is actually clear, but the devitrification minerals make it look black.
Yeah, well, that all got rolled up into a story that's a new mineral and it's got your name on it.
Well, that's all right.
Aren't you right?
Just be careful how you say it.
Okay, I was wondering if we're going to be doing all this training on the moon before going to Mars, does that mean that we'll have to set up habitat and all of those things as well for an extended stay, or how does that fit into the plan? Will it be short trips to the moon to do some of these training sessions, learn these protocols? Thank you.
Well, I think a lot of that schedule I put together, there's a lot of overlap, and your preparations for Mars probably will go on simultaneously with developing not only going back to the moon, but actually developing settlements there. I see no reason why we can't have settlements on the moon. And once you can do that, of course, a lot of things come into play, such as tourism and things like that. Because the cost, as long as you're acting and continuously acting, and have long-term production contracts, the cost of all of this starts to go down. That's a very important component of I think, any future long-term program. And one reason why you want to make that commitment to long-term production contracts. But I would see, yes, the moon is a place for permanent human settlements. The resource support for those settlements will be both potentially fusion power here on Earth and the marketing of space resources, such as we talked about, for other activities, not just Mars, but Earth orbit activities will need those resources as well. Unfortunately, I don't have the microphone.
Yes, Dr. Schmitt, finally have a geologist ask this question. Do you think that there are some interesting interactions going on between the solar wind and electrical discharges at the Martian surface, producing things like the blueberries that have gone from one explanation to another?
Specifically the blueberries, no. That doesn't mean there aren't interactions taking place. As they take place with the Earth, aurora, for example, are part of that interaction. The blueberries, it really didn't surprise me at all, because if you walk around for example, the sandstone cliffs around Chaco Canyon, as I have many times out in Mexico, you see blueberries. I mean, they're concretions, they're little concretions that have grown in the sandstones. And it's not an unusual geological phenomenon. So the one thing it does require, though, I think, is that Mars' surface had percolating water, very clearly, a lot of percolating water at various times.
What about interesting anionic discharges at the surface due to the lack of an atmosphere, the solar wind or aurora's electrical ionosphere goes right to the surface?
Well, it goes close, but there is enough atmosphere to modify that, I think. But you're getting me into an area that I do not claim to have any expertise in. All right.
Thanks for that.
Last question? Oh, that's it. You'll have another chance.
Good evening, Dave Moran, Clemson Community College. How you doing? So, given that you had the experience to go to space as well as serve our country as a politician, and you had the insight as to the way our political system works, we know that the funding for a lot of this is going to have to come through Congress, and we need 100% commitment from our elected leaders. What do you see as a way to motivate them to, like, let's make this happen?
Get active in the current political campaign. Somebody, if this is going to happen anytime soon, somebody in the current crop of candidates has got to pick up the ball, and in fact they all should, and say this is important for our national security, as well as important for the future of Americans. That I think is critical. So I urge you all to get involved with the various candidates of choice, and make sure they understand this is an absolutely critical future arena for activity by the United States.
Thank you.
Thank you.
Dr. Zugan can introduce you first, and then we'll go up. Yeah, we'll do that.
Who's our PC operator? So, and Cal, you're going to use a PC? I can. You can get this out. Okay.
Na razie tyle
Our next
samej
speaker
Marii.
is going to be Dr. Harrison.